What if the speed of light on Earth suddenly dropped in half? At first, it sounds like a complete disaster. We imagine a world where everything starts to lag. Sunlight takes a little bit longer to reach your face in the morning. The light bulb in your room flickers on with a tiny, perceptible delay. Your Wi-Fi feels like it's been thrown back to the dial-up era, a constant, frustrating buffer. But here's the weirdest part. The most mind-bending piece of this puzzle is that you wouldn't notice at all. Why? How could something so fundamental change without us realizing it? Because if everything slows down at the same time, our perception of normal just shifts right along with it. Think about it. Our brains run on electrical impulses zipping between neurons. Our vision is literally a flow of photons hitting our retinas. Both of these processes are governed by the speed of light.
If the cosmic speed limit gets cut in half, those photons slow down. The electrical signals in our brain slow down, which means we slow down along with them. The entire world gets slower, but our perception of the world gets slower too. The movie is playing in slow motion, but the projector in our head is also running in slow motion. So from our seat, the film looks perfectly normal. It's kind of like watching a snail. You might be standing there, tapping your foot, thinking, come on, hurry up. But from the snail's perspective, everything is fine. It's moving at snail speed, in a snail's world. Nothing is wrong. We'd be the snail. The whole world slowed down, we slowed down too, and nobody would have the slightest clue that anything happened. It's a silent, universal change that leaves no witnesses. But just because we wouldn't feel it, doesn't mean the universe wouldn't. The laws of physics would be rewritten overnight. Einstein's famous equation, E=mc², would be fundamentally broken. The c stands for the speed of light, and it's squared. So if you cut c in half, the energy you get from any nuclear reaction drops to just 1/4 of what it was. Nuclear power plants would suddenly become massively inefficient. The sun's own furnace would change its output. Our technology, built on the assumption of a constant speed of light, would go haywire. Your GPS, for example, works by measuring the tiny time difference between signals from satellites orbiting Earth. It requires near perfect timing. If those signals suddenly took twice as long to arrive, every GPS on the planet would think you were hundreds of miles from where you actually are. Our entire global navigation and timing network would collapse. So we'd exist in this strange paradox. Subjectively, inside our own minds, life would feel exactly the same. We'd wake up, drink our coffee, and go about our day, completely oblivious. But objectively, the physical world would be operating under a new, slower set of rules. We wouldn't notice the lag, but the physics that holds our world together definitely would. We are, in the end, just passengers, moving at the speed of the reality we're given. And if that speed changes, we just change our definition of now. Imagine light slowing down, not in a lab, but everywhere. It's not science fiction. In 1999, scientists at Harvard actually did it. They took a beam of light and slowed it down to just 38 miles per hour. You could have outrun it on a bicycle. It was a stunning achievement, but it was contained. So what if it wasn't? What if tomorrow the universal speed limit for light just dropped? Not just in a lab, but for everything. For the sun, for your light bulbs, for the screen you're looking at right now. Your world wouldn't suddenly go dark. In fact, at first, you might not notice a thing. Let's start with color. We see the world because of light waves bouncing off of things and into our eyes. An apple is red because it reflects the specific wavelength of light we call red. If light itself slowed down, those waves would behave a little differently. The shade of red might objectively shift. But here's the trick. Your eyes and your brain, which are governed by the same physical laws, would also be processing everything more slowly. The light, the apple, and your perception would all be in perfect, sluggish sync. You'd still see that apple as red, not some new, slightly off red.
The experience would be identical. The same goes for the internet. Our entire global communication network is just light, trapped in fiber optic cables. A slower C would mean slower data. Websites would objectively take longer to load, but since your brain's internal clock has also slowed to match, you wouldn't feel the delay. Everything would seem to load at the same speed you're used to, only the cat videos on YouTube would still load as slowly as they always do. But beneath this illusion of normalcy, a crisis would be brewing. Data centers would have to work harder for longer just to push the same amount of information through the slower pipes. Servers would run hotter, demanding massive amounts of energy for cooling. Our entire digital infrastructure would be straining at the seams, burning through power, all to maintain an experience that only feels the same. The first crack in this illusion would likely show up on your phone: GPS. Your location is calculated by timing signals from multiple satellites down to the nanosecond. That calculation has one non-negotiable variable: the speed of light. If that number changes, even slightly, the entire system breaks. A signal arriving a few microseconds late doesn't mean you're off by a few feet, it means you're off by miles. Your navigation app confidently reroutes you, and suddenly you're in the middle of a field when you were aiming for the shopping mall. And honestly, haven't we all ended up somewhere unexpected at least once? We'd have to recalibrate everything: every atomic clock on every satellite, every algorithm on every device, just to find our way home again.
But the real chaos wouldn't be on our maps. It would be in the very rulebook of the universe. Consider Einstein's E=mc². C, the speed of light, isn't just a velocity. It's the fundamental conversion factor between energy and matter. Change C and you change the most basic relationship that governs reality. Our understanding of everything from nuclear power to the stars would be thrown into question. The meter stick we use to measure the cosmos would literally change because the meter is defined by the distance light travels in a tiny fraction of a second. Every calculation, every observation, every physics textbook would have to be rewritten. And yet, even in this new, slower reality, the world would be a bit less precise, but overall still functional. You would still see red. The internet would still feel like the internet. We'd adapt, we'd fix the GPS, we'd write new physics. And perhaps the most beautiful part is that some deeper truths would hold. There's a fundamental number in physics called the fine structure constant, which dictates the strength of magnetism and light itself. Because of the intricate way it's woven from the other constants of nature, a universal slowing of light wouldn't change its value one bit. So while we'd be scrambling to understand our new, slower world, the underlying force that makes an apple red in the first place would remain perfectly, immutably the same.
Imagine the speed of light drops, not by much, but enough. And not everything slows down evenly. Light and all our electromagnetic signals, the internet, your phone, the very nerve impulses firing in your head now move just a bit slower. But the chemical processes on our brains, the cogs of consciousness, they adjust slightly differently. As a result, your mind might lag a fraction of a second behind the world or even jump a tiny bit ahead. The first thing you'd notice is a feeling of unease. The world feels jerky. Objects move normally, the laws of physics haven't changed, but you perceive them with an unusual rhythm. Let's say you toss a ball to a friend. It follows the exact same arc it always would, but to your eyes, its motion seems broken. It stutters through the air, making tiny, almost imperceptible jumps between frames. That's because your brain is processing the incoming light unevenly. This is a known phenomenon in a way.
It's similar to temporal light artifacts like the stroboscopic effect, where a flickering light can make a spinning fan look like it's standing still or moving backward. Now, imagine that effect woven into the fabric of sunlight itself. Your brain's predictive models, which have evolved to anticipate the trajectory of moving objects to compensate for its own processing delays, would be completely misaligned. This would create a constant disorienting sensation, much like the flash lag illusion, where a moving object appears to be ahead of a flashed object even when they're in the same position. This desynchronization would ripple outward, infecting all our technology. A video call with someone 1,000 kilometers away would feel strangely sluggish. Right now, a round-trip signal through a fiber optic cable that long takes about 10 milliseconds. But if the speed of light were halved, that latency would double.
the delay would become just long enough to disrupt the natural flow of conversation, a constant, frustrating lag. Our perception of color and contrast would warp. Under these new, dimmer conditions, our eyes might shift sensitivity toward the blue end of the spectrum, causing bright reds to appear dull and dark, a phenomenon known as the Purkinje effect. And we wouldn't be alone in this new disjointed reality. The experience would be a spectrum, depending entirely on the speed of your senses. Humans process vision at about 65 frames per second, but a dragonfly, which sees the world at 300 frames per second, would be plunged into a nightmare of fragmented, stuttering motion. Its entire world, built on reacting to microscopic changes in a fraction of a second, would shatter. Meanwhile, a crown of thorns starfish, which perceives the world at less than 1 frame per second, might not notice any change at all. Even among humans, the experience would vary. An older person whose cognitive processing speed may have naturally declined might find the jerky world profoundly disorienting. Someone with a condition like Parkinson's, which already affects time perception, could feel an even greater distortion. But here's the most profound question. Could we get used to it? The brain is a master of adaptation, a process called neuroplasticity. When one sense is lost, the brain can repurpose its old cortical real estate for a new job. It can rewire itself with astonishing speed to adjust to new sensory inputs. So perhaps over months or years, our minds would begin to compensate. New neural pathways might form, smoothing over the perceptual jitters. We might adapt so completely that the jerky rhythm of the world becomes our new baseline for what feels normal. And the smooth, flowing motion of the past, that would become a forgotten memory, a ghost of a reality we could no longer even imagine.
So the big question, if the speed of light suddenly dropped in half, what would we actually notice? The most likely, and maybe most disappointing answer is absolutely nothing. Think about it. Every process in the universe, the electrical signals firing in your brain, the chemical reactions powering your muscles, the photons streaming from your screen to your eyes, they would all slow down proportionally. Your perception is built from the same physical laws as the world you're perceiving. If the whole system slows down together in perfect sync, it's like trying to measure a shrinking ruler with a ruler that's shrinking at the exact same rate. From your point of view, nothing has changed. The cosmic metronome just ticks a little slower for everyone and everything at once. Life would feel exactly the same. But that's the boring answer. Let's imagine for a moment that we could perceive the change. In a universe with a slower speed of light, the strange rules of Einstein's relativity would crash into our everyday lives. Time dilation, the idea that time slows down for moving objects, would no longer be a concept reserved for astronauts in sci-fi films. A simple cross-country flight might leave you a few noticeable seconds younger than everyone you left behind.
Driving on the highway would literally slow down your personal aging process compared to someone sitting on their porch. You'd also witness length contraction. A person jogging past you wouldn't just be moving, they would appear physically compressed, squished in the direction they were running. The world would become a funhouse mirror of warped space and time. And that's just on Earth. If we looked up at the night sky, our entire understanding of the cosmos would be rewritten. A light year, the distance light travels in a year, would now be half as long. All those galaxies we thought were impossibly distant, they'd suddenly seem much closer on our cosmic map. But there's a flip side. The age of the universe is calculated based on how long the oldest light took to reach us. If that light was traveling at half speed, it means it was on its journey for twice as long. Our 13.8 billion-year-old universe would suddenly be revealed to be nearly 28 billion years old. We'd be living in a cosmos that was simultaneously smaller and vastly more ancient than we ever imagined.
Now, let's explore the truly terrifying possibility. What if the slowdown wasn't synchronized? What if physical signals slowed down, but for some reason, our biological processes didn't? This scenario is pure science fiction, but it's a chilling one. Your brain, still running at its original speed, would be trapped in a world moving in slow motion. A dropped glass would seem to hang in the air for an eternity before shattering. Conversations would be agonizingly drawn out. Your senses would be feeding you information at a pace your mind could no longer comprehend, creating a dizzying, nightmarish lag between you and reality. Your own body would feel alien, out of sync with your thoughts. Thankfully, an asynchronous slowdown like that is almost impossible. For your biology and the outside world to desynchronize, there would need to be some artificial, physics-defying barrier separating your biology from the universe it inhabits. In reality, there's almost no way for that to happen. Except, of course, for BMW drivers, who already seem to live in their own accelerated, out-of-sync world, completely independent of the physical laws the rest of us are stuck with.
What do you think about this? Share your thoughts in the comments. I'd love to hear your opinion. If you enjoyed the video, give it a like and subscribe so you don't miss the next What If.